Okay, good afternoon. Thank you for coming, everyone. I'll start with a couple of introductions. So my name is Dale. I'm joined by my colleague, Amelia. We're developers from IBM. We spend our time working with Apache Kafka. But in particular, we're interested in how we can enable developers to describe what they're doing with systems like Kafka. So we're going to be talking about AsyncAPI. Quick show of hands before we start, please. If you know AsyncAPI, used it before, familiar with it, hand up, please. A few people. OK. I'll try and think of something new to tell you, hopefully. But for the rest of you, this is good, because we're going to be hopefully showing you a tool you haven't seen before. So let's get started. I'm going to start, before we jump into AsyncAPI, by talking about the problem that it's trying to address, what it's doing. So as I mentioned, we work with Kafka all the time. So we're going to just keep mentioning Kafka because it's what we're used to. But everything that we say, you could equally be doing with like a RabbitMQ or an MQTT broker. Or so, you know, when you hear us say Kafka, insert your preferred flavor of asynchronous message brokery thing, yeah? Because otherwise we will completely forget to keep saying other things are available. So let's. So actually, we didn't help ourselves by sticking a Kafka logo in there. What goes on a Kafka topic and other types of queues and topics are bytes, streams of bytes. As far, you know, Kafka doesn't know what those bytes represent. Kafka doesn't care. It's just an efficient way of getting bytes from one app to another. So your producer is going to put something on the topic, and your consumer is going to receive that. Next slide, please. And you know, if the producer was serializing an integer, then those bytes represent some int. So the consumer needs to know that. It needs to know when it reads the bytes off of the topic that what it's doing is reading an int. And that's how having those two in sync is how you make that useful in your apps. Do you want to take this? Or? It doesn't have to be primitives, doesn't have to just be ints, doesn't have to be strings. You can have complex objects. And this is where you get into the world of schemas, where you describe the stream of bytes on this topic represents a string followed by an int, followed by a list of booleans or whatever.
And these are some of the popular schema formats. So first up is a JSON schema. This is a vocabulary that allows you to annotate and validate JSON documents. It can be used to describe any existing data you already have in JSON format. It's clear and readable for both humans and machines, and there are code and schema generators available with the support for many languages such as Java, Node.js, and Python. Next is Protobuf. This is a mechanism for serializing structured data. It's created by Google, and they describe it as language neutral, so it can be used to define message formats in a way that is independent of any specific programming language. For example, you could define a message format using Protobuf and then use the Protobuf compiler to generate code for Java, C++, Python, or any other supported languages. This allows you to define your message formats at once and then use them across multiple languages and platforms. It's slightly less readable than JSON and has a bit more of a learning curve. Finally, we have Avro. It's a compact binary serialization format that's designed to be highly efficient and language independent. It looks similar to JSON, but has support for a number of more complex data types. Also, binary encoding makes Avro more efficient, and it does not support references between schemas, unlike JSON. Those are all the schema formats I'm going to mention today, but there are plenty more. Schemas only tell you data types and field names, and as a developer writing an app that will use the data, knowing the field name and type isn't enough. For example, is length in meters or miles? There isn't enough context to use the data. This is where AsyncAPI comes in.
So we're absolutely not saying schemas aren't useful. They're absolutely foundational. But like Amelia was saying, what AsyncAPI is trying to do is to give you that additional context, to tell you where this data has come from, the systems that it's come from, put it in some broader context for you. So with that intro out of the way, don't worry, I'm not expecting you to read that. This is an AsyncAPI doc. It's a way of documenting your asynchronous API, hence the name. It's a way of documenting your queues, your topics, describing not only the data that's on them, but the system that it came from, what you can use it for, putting it in a broader context that describes what your application is doing. There are 4 main bits to an AsyncAPI document, and in our 26 minutes, we're going to try and run through and give you a feel of what's in each bit. We're not going to try and teach you the syntax, because there's no way you'd remember it anyway. We're just going to try and, our goal is to, so when you walk out, you have a feel for the kinds of things you would find in an AsyncAPI document. If you decide you want to write a document, which I hope you do, there are editors and stuff to help you actually do the syntax later. So the first bit is info. This is high level, this is narrative, this is context, this is explaining where these events are coming from. You know, what's the goal of them? What's the system doing? The font's a little bit small. I shouldn't have made it quite that small. So let me gesture wildly at it. There's a title at the top. There's a description. That description supports Markdown, so you can do, you know, kind of rich formatting, bullets, list. You can embed images. So, and we'll show you what these look like when they're rendered afterwards. You can do, I'm trying to think of other things you can do in Markdown. You know Markdown, you're developers. I don't need to explain that. But the idea is you're trying to make sense to the developer of what this topic, what this API is for, what can they do with it, that sort of thing. Contact details, super useful. You know, if you run into problems, something doesn't make sense, you're not sure how to use it, you need access to the topic. Having a point of contact of who owns that topic, who owns the apps that's putting the messages on the topic, such a simple thing, but as we're sort of saying, you know, schemas are good at describing data fields, but there's so many bits like this that they miss out. After that, there's things like tagging and licenses and all that sort of good stuff.
In the server section, it describes how to connect applications to your Kafka cluster. Some of the things it contains: the bootstrap address for your Kafka cluster, the version of the brokers that you're running. It also has a description section to provide any other information you think is useful. You can include multiple server objects, and each server is identified by a unique name, which is used to reference the server from other parts of the AsyncAPI document.
Oh, and just one other quick, if we can. Just keep reminding myself to say other things than Kafka are available. So you can see near the top, well, you probably can't, it's very small, it says protocol and it says Kafka. So that's where you can sort of say if that's an MQTT or I can't think of anything other than MQTT. JMS, what other protocols are there? You can tell I just do Kafka stuff all the time. But my point is, this is kind of agnostic of any individual protocol. It's a generic way of describing where your message broker is, where to go and find those events. Channels. So channels is kind of a way of describing what I would think of as topics, but because this is protocol agnostic, they've kind of gone for a generic term that covers all the bases. So for me, when I see channels, I think topics. But you might think queues, for example, depending on where you're coming from. Just quickly also on channels, I should say, as well as describing the topics or the queues, you're also describing the data, the messages that are going to go onto them. So we were saying before, you know, schemas. So in the Kafka world, we use Apache Avro for a lot of things. AsyncAPI isn't trying to replace that. Absolutely, carry on using Avro, carry on using schema registries. They're awesome. So you can embed. Could we switch to the example? The one in the browser. If you've got an Avro schema, you can refer to the Avro schema in your AsyncAPI doc. You can do $f and then point at where that Avro schema is. So what the AsyncAPI doc is giving you is kind of like an envelope, a wrapper. It's got everything that you've described in your Avro schema, but it's adding to that all that context we were talking about, that description, that narrative, that background, those contact details, the address of the Kafka server, and all of those other good things. So don't see this as us saying, use AsyncAPI instead of using schemas. What we're saying is take all the stuff you've already got in schemas and then wrap it in an AsyncAPI envelope that allows you to put all that additional developer documentation and context that developers find so useful. You know, the stuff that we love writing. So I just really wanted very quickly to show you what we mean by when we say in the channels section. So messages, you've got, again, Markdown supported bits to put descriptions and titles and summaries. You can describe the headers. So this one is actually doing like JSON schema format, but my point is you can describe the payload, all the different fields, all the stuff you'd expect in a schema, but also now available here.
In the components section, it contains reusable definitions that you can use in multiple places. For example, if you have several messages that share the same data schema, you can define that schema in the components section and reference it rather than duplicating the schema definition in each message. The ability to refer to a definition that is somewhere else is useful, as it avoids repetition and can help keep your AsyncAPI document more organized and maintainable. We now have some demos to show what you can do with AsyncAPI. The first one we've got is generating documentation. So there are command line tools you can use that will automatically generate documentation for you. So you can see here that it created all the files we need. And if we open this in a browser, you can see the documentation it made. So here it just instantly automatically generated all of this for us, and you can see it contains links to all the sections for the documentation. And this was just from uploading an AsyncAPI schema, it created this for us. You can also generate mock data. Microx is an open source platform for testing and mocking APIs. It works with many different API specifications, including AsyncAPI, and it generates mock data for your API based on the schema you provide. So if we upload the schema here, we can see that it's created a Kafka topic for us, and it will automatically start generating messages based on the description in the spec we provided. This means that without writing any code, we can have a real Kafka topic with real messages, and developers writing applications to consume these events have a source of data they can start developing against right away. Similarly to generating documentation, you can also generate code. I'm just going to make a small change to this to change the topic name because Microx changes it slightly, but yeah. So you can see, again, it's created the files for us. And you can make any logic changes you want to the code here. So for example, we're going to add in some connection details so it can connect to our secure Kafka cluster. Now it's ready to build this and run it, and then we'll have a subscriber for the topic we just created using Microx. Oh, sorry, I just realized I didn't save the schema, so we'll have to run that again, but no worries.
I can fill while you're doing that.
Yeah, please.
So to recap what she's shown there, you've written a doc to describe the messages for your Kafka topic. So from that YAML document, she generated a web page. So imagine if you've documented all of the messages your application's producing with a single command, you've now got a folder full of HTML pages that you can then publish there. GitHub pages, stick it in a branch. Put, if some GitHub Actions thing that as you change the spec of the messages you're producing, you can run that single line command that gives you free and simple, you've suddenly got developer documentation for all of your queues and topics really, really easily. And then she showed Microx. Spec first development is something I always aspire to. Don't think I've ever done a project where we've actually properly done it. But that idea of everyone agreeing up front, this is what the shape of the data is going to look like. This is what we're going to do. This is it. Once you've got that in a document, instead of the people writing the apps to consume the messages having to wait for the team who are producing the messages to have done that, what she showed is you upload the document and it just creates a topic and starts creating the messages for you. Every few seconds, a new randomly generated message. So you don't have to wait for, that decouples your individual squads, assuming you have squads, but your development teams can all work independently because the spec is the thing that they're agreeing on and working to. Yep. And now it's working.
Yeah, you can see here that's receiving messages from the topic we set up. We configured it to send a message every 3 seconds, so you can see here every 3 seconds when it's coming through.
And the last demo she showed was to go from 0, an empty folder, to a scaffolded out, I think that project was Maven, ready to compile. That it's all the code for a working app that knows how to deserialize the messages is ready to go. Maven package, and then I think it was Java -jar to run it. To go from just having a document where you've agreed on the shape of the message to a running app that you can start adding your logic, that's the kind of thing AsyncAPI is here to help with. Oh, for our last demo, we'll do EAM. So one thing I forgot to say is, have any of you used OpenAPI before? Or Swagger, as it used to be called? Right, so I should have checked that first, because I could have been relating what we're talking about to that. Because what you probably saw, even without me pointing it out, is there's a lot of similarities, right? OpenAPI, AsyncAPI is absolutely proudly inspired by the lessons that have been learned from OpenAPI. It's kind of an unofficial sister project that's taking all those lessons that have been learned from documenting APIs and bringing it to the asynchronous world, where traditionally we haven't been as good at documenting stuff. So if you take that idea of, what does OpenAPI docs enable you? It enables stuff like API management, API portals. So taking that idea of now we've got in AsyncAPI, we've got a way of describing our asynchronous APIs. We can have asynchronous API portals too. And that's what we work on. If you will forgive us a brief shameless plug, but it's another example, and absolutely other flavors are available. We're not trying to say we're the only ones. But what you've got here is a way of, if I go into topics, so I own a Kafka topic. I want other developers in my organization to use it. I mentioned one super cheap way I could do this is just run the HTML generator and then just share that HTML file somewhere. And that's a really good way for small teams to start. But this way is just putting a nice UI on it, allowing you to, so if I go into edit, it means I can do all that contextual stuff of describing the APIs, describing the schemas. And as you see, still not trying to replace Avro. So for that topic, it is using a traditional schema registry. So just sort of pointing at that Avro schema. But what that means is another developer in my organization can come along, see the topics that have been published in a catalog, discover the topics that are useful to them, read about it, see what the payload looks like, see sample messages, that sort of thing. And taking that idea, that analogy of API management one step further, self-service access to create themselves credentials. So they can create themselves credentials that will go to a Kafka API gateway. So this idea of putting some management layer in front of your backend messaging systems. AsyncAPI makes this all really easy. That all those lessons we've been learning over years of API management and describing and documenting and sharing and socializing our APIs, AsyncAPI is kind of enabling us to do that with our queues and topics and our asynchronous things as well. What were we going to do next?
V3.
V3, that was it. So browser window. So one thing before we go, we just wanted to talk about V3 is kind of the next, not yet published, upcoming version. I just wanted to sort of give you a bit of a sneak peek about what kinds of changes are coming, and then we'll stop and we've got some time for questions. So it is really similar. So I'm just going to sort of pick out the differences from what we were saying in the V2 stuff. So it's still like a YAML JSON document, so it's not going to look massively different. It's been slightly reshaped. So some of these bits like tags and external docs that were in V2 top level standalone things, now they've been folded under info because that's kind of where they always belonged anyway. The most contentious bit about AsyncAPI V2 was trying to choose the verb of how to send, and where I'm looking for where it is. Here we go. Every operation in an AsyncAPI doc today is a publish or a subscribe. But as new protocols have started getting involved, publish subscribe doesn't always make sense, particularly if it's like a queue-based thing. You might be doing like a puts or a gets or something. So in V3, it's going to become a bit more generic, a bit more agnostic, and the verbs are becoming send and receive. But it means the same kind of thing. It's just in a way that isn't only very pub-subby. The document's been slightly restructured. I won't go into all the gorpy details, but the goal is to try and, Amelia was mentioning about components, reusable bits that you can refer to elsewhere in the doc or in other docs. So it's been broken apart to make that easier. So things that, whereas before in V2, a message was a child of an operation, and an operation was a child of a topic. So you would have a topic, and then it would have two children, a publish and a subscribe. And then those operations would have a children of what message they're publishing or subscribing, which is good to start with. But if you've described your message once, you kind of want to use it on multiple topics. So this idea of decoupling it so that the operation is a first-class standalone citizen, that's helped enable that. I think those are most of the changes that you would need. There's a couple of minor like syntaxy changes, but other than that, the big drivers was breaking it apart to make it composable, changing from publish, subscribe to send and receive, and a couple of the minor bits have moved around. So that's kind of what we wanted to talk about with AsyncAPI. We wanted to give you a bit of a flavor of what problems it's solving, that idea of developer document, didn't mean to play from start, supplementing what we can do with schemas by providing broader contextual documentation, and that it's not just writing documentation for the sake of it. The reason we wanted to show you those demos is to sort of show you that if you invest the time writing a bit of docs, it enables all sorts of other cool things you can do. And there are loads of other tools, like in a 30-minute talk, we didn't have time to go through them all, but the ecosystem, the community around AsyncAPI is really active, and there's always new tools and things coming out. There's low-code prototyping tools that you upload your AsyncAPI document, and it gives you a node representing your queue or topic that you can then wire into other things, and loads more besides. Lots of different flavors of generator. We pick Java because we do a lot of Java, but there are code generators for loads of languages. So if you've got another language in mind, give it your AsyncAPI document, and then you get a working project ready to compile and run in your language of choice. But with that, any questions? I think someone's going to run at you with a microphone. That sounded more threatening the way I said that.
Doesn't sound like it's on. Hello.
There we go.
Thank you for your talk. Really interesting. Is it, with OpenAPI specs, obviously we've got a lot of projects who we do the opposite, where we convert code into docs. Is that feasible at all?
So I know I've been working on a project to do that. It's still a little bit skunkworksy, and I'm fairly sure I'm not the only one that's doing it. So that idea of you've already got your app that is producing messages to a topic, and certainly with something like Kafka, where you've got that retained message log, you've got all the messages on the topic, to be able to point an app at a topic, and then it generates an AsyncAPI doc from what's on there. So I've got like a really rough working version of that. So my name was on one of the slides, Dale Lane. So github.com/Dale Lane. If you look at my repos there, you'll find one. It's still a bit rough and ready, but I'm fairly sure I'm not being super original with that. So I think it's a totally valid idea, and I think there's going to be more things like that around soon.
Yeah, first of all, thanks for the talk. My question is, I think, related, because a lot of us probably use Swagger, and there is an option also to start with the code and annotations, and then, first of all, you have some UI out of the box, but also you can generate an OpenAPI spec, so you can share with others. And do you envision something like that for AsyncAPI as well, so that you can annotate your code that is producing, consuming, and get spec that way?
That's a good point. I hadn't thought of that. I know I have seen Spring-based generators for AsyncAPI, but I don't do Spring, so I've never tried them. I don't know, I guess is the short answer, but I think as a general rule, like the way you're thinking about it is how I think about it. That we don't want to reinvent any wheels here. So like where we've learnt lessons of what can be done with OpenAPI and Swagger, trying to bring those lessons across is absolutely what a lot of us are doing. So I'm sure someone has probably done it. I just haven't used it or seen it myself.
A question about versioning, because events evolve.
Yep.
How do you deal with perhaps maintaining 2 versions or more at the same time, while an application is being upgraded or rolled out, where not all components simply can switch over at the same time?
Yeah.
We have deprecations of fields, etc.
I'm trying to remember where I put. So there's lots of different ways you can do it. So if you're doing Avro schemas, Avro's fairly mature at doing compatibility inversion, and given to Avro schemas, there's like formal ways of knowing if it's forward compatible, backward compatible, and so on. So if you're just using AsyncAPI to wrap your Avro schemas, that's kind of easy. You just point at that. But what I showed here, we didn't really have time to go through it, but when I wrote this example, I tried to show how, if you're doing more of a JSON schema kind of way, how you could do that sort of compatibility. So at the top level, I said that my message, any message you find on this topic, because remember again, with Kafka, it's retained. So it's not just about saying from now on, I'm going to publish messages of this new shape. You still have to describe the fact that the older messages on the topic were produced in the old shape. So what you have is this sort of one-of way of saying every message on this topic is either going to be a version 1 or a version 2. And then you say that which field is going to be the one that lets you determine which shape it is, which I called version, and version is an enum that's either v1 or v2. So then you've got a separate schema for each. So my v1 schema has those fields as required, and my v2 schema has additional required fields. So it's it's not like there's an out-of-the-box easy way of doing it, but the syntax does allow you to express that idea of you've changed the shape of your data over time. You can totally describe all of that in the document.
Hi. Considering an ecosystem of microservices, what would you recommend as a location to store these API definition files? Would you have a separate repository containing all the files, or the consumers should have the files, or the producers should have the files? What would be the right place?
So I mean, we're kind of biased. Like, we're going to say that the best place to store them is in our product, but not really, I'm kidding. I personally would keep them as close to the code as possible, because my experience is if it's not tightly coupled to the code, you will forget to update it. Like, I suck at updating docs. So keeping it as close to the code as possible. And I like the idea, like I was saying, of if you can do that sort of doc generation that we showed, like as part of pull requests, so it happens automatically. When you update one thing, the other thing gets updated automatically. With the V3 format, it's definitely geared to that idea of building up that microservices, describing your whole solution, your whole microservices architecture, not just an individual component. And that's been a lot of the motivation for making nearly now everything in the spec. In V2, bits were, but in V3, everything in the spec can have that dollar reference to an external file. So you could have one async API. On the other thing we changed in V3, I forgot, is now lots of components are now optional that used to be required. Because in V2, an async API document had to describe an app, a specific thing, like AQ or an app. Whereas with V3, an async API doc can just be like an import file. Like, here's all my common stuff that doesn't describe anything by itself, but all my other files are referring to it. So if you've got your standard message formats, have that in one file that all your different docs can point at. Or if you've got your standard message broker that all of your topics are on, don't copy that server information that we showed. If all of your messages are going to be on the same Kafka cluster, don't copy paste that into 17 places. In your one common imports async API doc, describe your server and then import it in all the others. So yeah, I think that idea of building up a folder structure of all your async API documents and keeping that close to your code, that would be my starter. I didn't realize how blinding it is standing here.
Thanks for the talk. Actually, two questions. Do you also support definitions for WebSockets or server-sent events? And the second would be, how about cloud event spec? How does this relate to that?
So WebSockets, definitely yes. That is one of the protocols. So actually, it's nice that it's on the screen there. There are like multiple variants of each of the protocols. So there's Kafka and Kafka Secure. So there is WS and WSS that you can do. I'm not sure about server-side events. I've never used that, so I'd have to check that. In terms of cloud events, absolutely, I have seen people do that with AsyncAPI. Again, essentially wrapping their cloud event that describes the data payload in an AsyncAPI doc. And there is, I'm never going to find it now, am I? There's a format type where you say how you're describing the data. Here we go. So here we're using like the baked-in vanilla native async API JSON schema. So that's where I would put, if I had an Avro schema, I would say Avro, but if I was doing cloud events, I would put in the right string to describe cloud events. And I think we are out of time. So I hope that was useful. I hope that's inspired you to give it a try. Try documenting some of your asynchronous APIs. We're going to be around for the rest of the day, so please do come and grab us if you think of any more questions.